In our previous lesson, we have learned how sound is produced due to vibration, how sound propagates, and in what medium sound can travel. Here, in this lesson, let's discuss the characteristics of sound. By that I mean how we can determine the differences in two sound waves. We have already learned that a sound wave can be described by its frequency, amplitude, and speed. Let's discuss in more detail now. A sound wave, which you can see over here, represents how density and pressure change when the sound moves in the medium. The density as well as the pressure of the medium at a given time varies with distance above and below the average value of density and pressure. As we have learned in our previous lesson, compression are regions where the particles of the medium are crowded together. So in the sound wave, compression represents the upper portion of the curve. So we can say that compressions are regions where density as well as pressure is high. And rarefactions are the regions of low pressure and density. So in a sound wave, it is represented at the lower portion of the curve. The peak of a wave is called as the crest and the valley of a wave is called as the trough. The distance between two consecutive crests or two consecutive trough is called as the wavelength. It is represented by the Greek letter lambda. The SI unit of wavelength is meter. Now let's discuss about another characteristic of sound, frequency. Frequency tells us how frequently an event occurs. Suppose you're beating the drum. The number of times you're beating the drum per unit time is called the frequency of your beating the drum. We know that when a sound is propagated through a medium, the density changes from the maximum value to the minimum value. The change in density from the maximum value to the minimum value and again to the maximum value makes one complete oscillation. The number of such oscillation per unit time is called frequency. It is represented by the Greek letter nu and its SI unit is hertz. Now let's talk about the time period of a sound wave. The time taken for one complete oscillation in the density of the medium is called as the time period of the sound wave. It is represented by the symbol uppercase T. The SI unit of time period is seconds. Now just imagine a violin and a flute may both be played at the same time in an orchestra. Both the sound travels in the same medium, that is air, and both the sounds are of same speed. But yet the sound produced or sound we receive are different. Do you know why? This is due to the different characteristic associated with sound. Pitch is one of the characteristic. The faster the vibration of the source, the higher is the frequency and the higher is the pitch. Thus, a high-pitched sound corresponds to more number of compression and rarefaction passing at a fixed point per time. The magnitude of the maximum disturbance in the medium of the either side of its mean value is called its amplitude. The amplitude of a sound wave helps us to identify the loudness and softness of a sound. Yet we have discussed a lot about sound and its characteristics. But what about speed of a sound? Speed of a sound is defined as the distance at which a point on a wave travels per unit time. We know speed v is equal to distance upon time. Here, lambda is the wavelength of the sound wave. It is the distance traveled by the sound wave in one time period of the wave. So, v is equal to lambda nu, where nu is equal to 1 upon t. That is, speed of a sound wave is equal to wavelength into frequency. Here, in this lesson, we have discussed about characteristic of sound. Let's take a quick recap. We started with wavelength, which is defined as the distance between two consecutive crest or two consecutive trough. Then we have talked about frequency, which is defined as the number of oscillations per unit time. Then we discussed about time period, which is the time taken to complete one oscillation. Then we talked about amplitude, which we can define as the magnitude of the maximum disturbance in the either side of the mean value. Then we have related amplitude with loudness of a sound and frequency with pitch of a sound.